We now have three systems which are very similar to the previous problem. That is, there is a rod which is hinged at one end and connected to a spring at the other end. But the difference over here is that the rod is horizontal and the spring is vertical. At this point over here, the rod is hinged. That means the rod can move in this fashion. It's the spring which is preventing the rod from falling down like this. There must be a weight acting on the rod. The weight of the rod would be trying to bring the rod down in this fashion if it is hinged over here. It is the spring which is preventing it. The length of the rod is equal to capital L and the mass of the rod is equal to small m. And information is given to you that at the natural position, the rod is completely horizontal. Okay? This information is given in the problem that when the system is left as it is, the rod is completely horizontal. It hasn't bent like this. What you have to do is, if this rod is given a small disturbance downwards or upwards, you have to find out whether, in that case, the rod undertakes a simple harmonic motion, and if so, then find out what is omega, what is F, and what is T. Okay? This is the first problem. Remember, the important thing lies over here, that initially the rod is horizontal. You have to evaluate this statement very, very carefully. The second setup that I have drawn over here is basically same. Only difference is the spring has been moved. The spring is attached to the rod at the central position. Okay, this side is L by 2 and this side is L by 2. Other information remains same. That is, that initially the rod is horizontal. Okay, and then the rod is given a small disturbance like this, either downwards or upwards. You have to find out that once the rod is released, whether it would undertake SHM, and if it does, find out what is omega, what is F, and what is T. Same as the first setup. Only difference is the spring has been moved. Once you have solved these two problems, then comes the third case, which is an extension of these two problems. Let's say now the spring is located at a distance of x times L, okay, where x is a variable in the sense that you have to find out the omega, the F, and the T for the same information given. That is, initially the rod is horizontal, okay, and you have to find out if the rod is given a small disturbance, whether it undertakes a simple harmonic motion, and if it does so, you have to find out omega, F, and T. Once you have found out, you would see that possibly omega is a function of x. Possibly frequency is a function of x. Time period is a function of x. Okay? You have to find out, evaluate this function and comment how omega, F, and T changes as x changes. Basically, the point where the spring is connected to the rod, that is a variable over here. Okay, as the point of suspension keeps on changing, omega, F, and T possibly would keep on changing. You have to find out how omega, F, and T changes as the point of suspension is changed. Now, we would be solving the first case and the second case in the follow-up videos. The third case would be left as a homework. Okay, you have to solve it by yourself. Try these setups out. If you are not able to solve them, we will be solving them in the follow-up videos. So let's jump into the follow-up videos for the same. Thank you.